The next thing that you need to do is to complete this table. If you did not print out the lab handout, that's fine. Just make a quick data table on a piece of notebook paper. But from the videos, you should be able to fill in the mass of H2O2 and the volume of KMNO4 used. Do not worry about the initial and final volume because I already gave you those volumes. So go ahead and fill that out. And then I'm going to go through and tell you how to do the calculations. So the first thing that you're going to have to do with the calculations is balance this redox reaction. So this is an acidic solution, so please balance that. You can pause the video, and once you have that balance, then we will start again. So the next thing that you need to do is calculate the grams of H2O2 for each trial. So what you have to do is start with the volume of KMNO4, and you have to change that to liters. So this would be the last box down in the bottom of the table. Then we're going to use the molarity, which we said was 0.1000 molar. So 0.1000 moles of KMNO4 per 1 liter of KMNO4. The next thing we are going to do is use our two coefficients from our balanced redox reaction. So these are the two that we're going to be using. So we're going to use the coefficient for the MnO4 minus and the coefficient of the H2O2. And since that's in moles, we want to know grams of H2O2, so we have to calculate in 1 mole of H2O2, we need the formula mass of H2O2. And that is going to give you how many grams of H2O2 there were in each one of those trials. And then, once you have that number, remember that commercial hydrogen peroxide is not 100% peroxide. It's only 3% from the bottle. So we're going to see what the percentage was in our 3 trials and then average those. So your answer from up here, and I know it says number 3, it's actually number 2. So the grams of H2O2 that you got from up here for trial 1 over the grams of the sample in the beaker, which was from our table, so our mass of H2O2 right here, which is around 10 grams. And then you're going to multiply that by 100 to get a percent. And you're going to do that 3 times, and then you're going to average that. And the last calculation is you want to calculate percent error for this number. So the experimental value is your average value. The actual should be 3.00, and remember that percent error is experimental minus actual all over actual times 100.